Hi everyone, in today's video we will talk about a topic called integration. Now, last few classes we learned about differentiation, which is a mathematical tool and which is similar to the process of dividing, right? Similarly, we have another mathematical tool which is called integration, and integration is the reverse process of differentiation. So if differentiation is like dividing two things, integration will be like multiplying two things. So let's learn more about integration. Now let us see some simple examples where we multiply two things to find something else. For example, if you want to find cost of 10 apples, then what we should do? Find cost of one apple, which is called cost per apple, then multiply with 10 apples, isn't it? So if cost of one apple is 5 rupees, cost of 10 apples would be 50 rupees. So similarly, if I give you a physics example, then distance traveled in 10 seconds if I want, then if you know the distance traveled in 1 second, which is also called speed, then you just multiply that with 10 seconds. You will get distance traveled in 10 seconds. Similar to this logic. Or suppose you want to find mass of a rod, let's say mass of this rod, and its length is capital L. And what do you know? You know the mass per unit length, meaning you know mass of 1 meter, and this rod is, let's say, 10 meter. Then what will be the mass of the rod? Mass per unit length into total length, right? So if your mass per unit length is 2 kg per meter, then what will be mass of 10 meter? Just multiply with 10 meter. So that will be the mass of 10 meter, and that would be meter will cancel, 20 kg, right? Now let us use some symbols to represent these two quantities. So I'll call these quantities as y and these quantities as delta x. Now when are we allowed to multiply these two in order to find cost of 10 apples? We are allowed to do that only when the cost of each apple is constant, isn't it? As I go from one apple to the next apple, then to the next apple. So as I cover these 10 apples, as I change from apple to apple, the cost of each apple must be same. Then only we can multiply, right? So if cost of one apple is 5 rupees for all the 10 apples, then the answer is 50 rupees. But if one apple has 5 rupees, other apple is 9 rupees, another apple is 15 rupees, then we cannot multiply cost of one apple with all the 10 apples, isn't it? So please remember, this simple multiplication of y and delta x is only allowed when your y remains constant, when your y remains constant during the change of x. So as I change x by what amount? Delta x. In that interval of delta x, your y must be constant. Then only we are allowed this multiplication to find either this or this or this. Okay, so keep this in your mind. Now in a very interesting way, we can consider this product or this product as area of a rectangle. How? We can plot this quantity, speed, along y-axis, and we can plot time along x-axis, right? Now when can we multiply these two in order to find the distance? Simple, when during this interval, during the interval of 10 seconds, your speed should be constant, or during your variation of the apples from 0 to 10th apple, the cost per apple should be constant. So during this variation, let us say this is 2 to 12 seconds. So 2 to 12 seconds would be 10 seconds, right? So during this interval of x, your y should be constant. So if I plot the graph of the function, it will look horizontal to x-axis because your y should be constant. So now if you try to calculate the area under this graph by drawing these perpendiculars to x-axis, so if you calculate this area, I hope you all know that this is looking like a rectangle, right? So the area of this rectangle would be, your length is your y and your breadth is your delta x. So y into delta x. Right? Now as we discussed before, this kind of multiplication is only allowed when your y is constant. For example, here if speed is constant, then you can multiply speed and time to find distance. But you only know that in our day-to-day life, the speed is never constant, right? It keeps on changing, isn't it? So in that case, if your y is changing with x, then how are we going to find the product? Then how are we going to find the area? That is where the integration comes. So let's see that. So here I have taken an example where the y is changing with x and it is no longer constant. So now if I want to find the area, just like we did before, y into delta x, but now your y is changing, so the area is not looking like rectangle, and therefore I cannot multiply directly y with delta x because the y is not having a constant value. The y is changing and this shape is clearly not rectangle. Then how do I solve such questions? How do I find area under this graph? So the idea is we will consider a thin rectangle here. So the line which I have drawn here is actually, you have to imagine it as a rectangle whose length can be now taken to be constant as I go from this side of the black line to I go to this side of the black line. So as I go from, so imagine this is the black line. So as I go from here to here, I can approximately now assume that the y is constant, isn't it? Because I have assumed a very small rectangle. So for this thin rectangle, I can find the area by multiplying the length, which is y, with the breadth. And for breadth, which is nothing but thickness of the rectangle, it is so thin that there is no point writing delta x. So it is so thin that delta x tends to 0. And when delta tends to 0, we write it as d, isn't it? So the area of this black rectangle would be y into dx, and then we can divide this whole area into thin rectangles like this. Starting from here, then you go to the next rectangle, then you go to the next rectangle, then you go to the next rectangle, and that way till you reach this rectangle, right? So as I go from this point to this point, I have to find the area of each rectangle using this formula, and then I will add this area of each rectangle from here to here. So let's say this point corresponds to x1 and this point corresponds to x2. Okay, so I have to add this area, which is area of these thin rectangles, starting from this rectangle till I reach here. So I have to add this from x equals to x1 to x equals to x2. It's like going from your first apple to your 10th apple and adding the individual prices of each apple. So you start from this x1, you go to this x2, and keep adding these thin rectangles using the formula y into dx. So again, this is only allowed when y is constant, remember, and that is why you have to choose a very thin rectangle. Then only you can assume y is constant. If your interval is very large, then it's very clear that in this large interval your y is not constant. But in this very small interval, you can see your y can be taken to be constant. I always give the example, from birth till today, obviously your height has changed. So in large interval of time, obviously your height has changed. But for a small interval of time, let's say for 1 nanosecond, I can always assume your height is constant. Now, mathematically we write this, adding y dx from x1 to x2, we write this as this symbol we use, which is the symbol for integral. So basically this is saying add. What we have to add? Y dx. Remember, y is the function. From where to where? x1 to x2. So this is called the starting point, which is called lower limit of the integral, and this is called the upper limit. So we can write from x1 to x2, and that is how we are going to calculate the product, which is the area under the yx graph between x1 to x2. So this is the meaning of integral y dx from x1 to x2. Now the formulae of integration can be found by remembering that integration is the reverse process of differentiation. So if you take differentiation of a with respect to x and you get b, then when you integrate b dx you should get a. So that's the meaning of reverse process. So we have learned in differentiation that if you take dx cube by dx, the formula was nx power n minus 1. So here n is 3, so 3x power 3 minus 1. 3 minus 1 would be 2. So what is differentiation of x cube? 3x square. Apply this logic. So integration of 3x square will give you how much? X cube, isn't it? Now if I don't want 3 here, then what will I do? I will divide both the sides by 3. So integral of x square dx will be x cube divided by 3. Right? Now we can generalize this formula. Here power is 2 and here it is 3. So this is 1 more than 2, isn't it? 3 is 1 more than 2. So if this was n, this would be what? N plus 1, isn't it? Because when this was 2, this was 3. So if this is 4, this will be 5. So if this is n, this will be n plus 1, and in the denominator we have n plus 1. So this would be the formula for integral of x power n dx. Now in second PU maths, when you will study integration, they will usually put here plus some constant. We will not do that because in physics whenever you do the integration there will be lower limit and upper limit. So if there are limits, then we don't have to put the constant of integration. So just try to remember the formula. Integral x power n dx is equal to x power n plus 1 divided by n plus 1. Let's apply this formula which we recently saw into this question. So here n is 1. So what will be the answer? X power 1 plus 1 divided by 1 plus 1. That will be your x power 2 divided by 2. So try to remember this. Integral of x dx is equal to x square by 2. So as I just told you, in physics whenever we do integration of some function, so this is not y into x, okay, this is saying y is a function of x. So just like I gave you integral of x square dx, so think of this as x square. Then what will be this? Some different function. So when I do integral of x power n dx, what is the formula? X power n plus 1 divided by n plus 1. Now let me tell you, if you have limits, then what we should do? If you have limits, let us assume a and b, then after you apply the formula for integral of the given function, as I told you, if this is x power n, this will be x power n plus 1 divided by n plus 1. Now you write the limits here and here. This is the upper limit, this is the lower limit. After that, wherever there is variable x, there you substitute the upper limit first, then put a minus sign and then you substitute the lower limit. Now let me try to explain why this rule works, why it works. So for that, let's say I have a rod which is kept on x-axis, which is in meter, and it is kept such that one end is at 2 and the other end is at 8 meter. Then what is the length of the rod? Obviously the length of the rod will be 6 meter. From 2 to 8, 8 minus 2 is 6 meter. But let's say we try to find the answer in a different way. We'll use integration formula. So let us say I divide this whole length into small pieces, and one such piece is this red piece which I have shown here. The length of this small piece, let me call it dx. So if I add this length dx, then this length dx, then this length dx till I reach here, then I should get the total length of the rod. So let's try to do that. So I take dx, which is length of one small piece, and then I add. When I say add, I mean integrate. From where to where? 2 to 8. 2 to 8. Now, what is the formula for integral of dx? Well, integral of dx is x. Now, how do I get that? Well, I have given the formula before. Integral of x power n dx is equal to x power n plus 1 divided by n plus 1, isn't it? So if my power is 0, then this will be 0, this will be 0, and we all know x power 0 is 1. So integral of 1 dx is x power 0 plus 1 is x power 1 divided by 1, which is simply x. and 1 into dx is dx. So integral of dx is what? X. So integral of dx is x. Then what the rule says? It says we have to put here square bracket and then upper limit here, lower limit here. So upper limit here, lower limit here. After that, what I should do? Wherever is x in the function, you have to put the upper limit. Then minus wherever is x in the function after you do integration, remember, not before you do integration. So after applying the formula of integral of dx is x, wherever is x, you put upper limit, then minus sign, then wherever is x, you put lower limit. Here x is the variable. So wherever is x, put upper limit 8, then put a minus sign, then put wherever is x the lower limit, and 8 minus 2 will be 6 meters. So I hope you understood the reason why this technique works. So why there is no plus? Because if this was plus, here also plus you will write, then the length of the rod will come 10 meter, which is nonsense, right? Because the length of the rod must be 6 meters from 2 to 8. So therefore this must be minus, right? Now let us do one application of whatever we have learnt. Imagine I give you a rod which is made up of uniform material, matlab same material. So if this part has 2 kg mass, this part also has 2 kg mass, this part also has 2 kg mass. Why? Because it is same material. So if the mass per unit length, meaning mass per meter, mass of 1 meter, if that is, let us say, lambda, and if that lambda is constant, then how will you find mass of the entire rod whose length is capital L? Simple, you will multiply the mass per unit length with length, isn't it? Right? So this is like saying, this is like your cost per apple. Then how will you find cost of 10 apple? You will multiply the cost of 1 apple with 10 apple. So this is mass per unit length. If you multiply with length, you will get mass. But again, just now we discussed, this multiplication is only allowed when lambda is constant. But what if, students, we have a rod which is not made up of same material? Let us say, as you go from this end of the rod to this end of the rod, let us say the atoms are coming closer and closer and closer. If that happens, then this part, this much part will have less mass, this much part will have more mass. So now your mass per unit length, lambda, will not be constant. In fact, it will change with x. So let us assume the function is given to be 3x. So now how will you find the mass of the rod? Let's discuss. So it's quite easy, because already we have discussed that this was y in our previous example, and this L is your delta x. So as you change x, if y is constant, remember I told you, then we are allowed to multiply. Similarly, if here your x is your L, so as you change the length of the rod from 0 to L, as you go from 0 to L, your lambda mass per unit length, if it is constant, then you can multiply to find the total mass, isn't it? But here we cannot directly multiply lambda with L here. Why? Because lambda is changing, isn't it? So if lambda is changing, which means y is changing with x, then what was the technique we discussed? First we have to find y into dx, and then we have to integrate to find the product. And here the product of mass per unit length with length will give you mass. So now this is how you have to find the mass. The only thing is you have to replace your y with lambda, because here lambda is function of x, isn't it? And from where to where I should integrate? From 0 to L, from 0 to L. So now what I should do? Substitute this lambda here, 3x dx from 0 to L. Then 3 is constant, you can take it outside, and integral of x dx. What's the formula? x square by 2 and L 0. Then the next step is wherever is x, we put the upper limit. Put the upper limit here, L square by 2. Then put minus lower limit. Lower limit is 0. So the answer is what? 3L square by 2. And that would be the mass of this rod. A very interesting application of integration is to find area of a circle. So suppose I have a circle whose radius is r and I want to know this area of the circle. Now you all know from your school that the formula for area of a circle is pi r square. But can we derive that formula? Yes, we can do. We just need to know formula of rectangle, which is length into breadth. But how are we going to do that? Well, the idea is this. We can imagine this disc or this circle is made up of rings. Okay, so we can imagine this whole circle is made up of this ring with 0 radius, then this ring with some small radius, then this ring with another increasing radius, then this ring, then again this ring, then again this ring, again this ring, then again this ring. So like this we will we'll divide this disc into rings, thin rings, and we will add the area of each ring. And if you add all the areas of the rings, you will get the area of the circle, isn't it? And you will see this in real life if you cut a tree, which is a very bad thing to do, but let's say there is a cut tree already, and if you see the cross section, you will see that disc of the cross section of the tree looks like it is made up of rings. Okay, so let us take one such ring here. So this red color is the ring whose radius is x, and this thickness I have used dx. So what would be the area of this ring? This part I am asking. So how will I find that area? Let's say I cut this ring, I cut it and then I open it. So if I open it, it will become a line, isn't it? Right? And the thickness of the line will be this thickness, which is dx, and the length of the line would be this circumference, and circumference of a circle is 2 pi radius. Here the radius is x. Now some of you may argue, how did I take the radius x? Because the inner part of the circle has radius x. Outer part will be how much? X plus dx. But x plus dx is obviously very close to x because dx is very small. So when you add x plus dx, you can consider it as x. When you add or subtract, remember, not when you multiply. So when you add x with dx, you can neglect dx because it is very small. So once I do that, this area of this line can be assumed like a rectangle, right? So for a rectangle, if I give you the length is L and breadth is B, then what's the area of this rectangle? Length into breadth. So what will be area of this line? Length is 2 pi x, and the breadth here is the thickness, which is dx. Now what is this, students? Remember, this is the area of this ring. So now we have to add this area. Add means what here? Integrate. Starting from where? Well, you have to start from this ring, which is a dot at the center, and dot at the center will have what radius? 0. So your x, when you start from this ring, right? If I had made the ring here, then what would have been the radius x? 0. So your x, which is a variable, starts with 0 and then it goes up to what value? Well, you have to make the ring up to here. So if you make the ring here, what would be your x? Your x would be this radius. So x would be r. Right? So the idea is you divide this whole circle into small rings. This is the area of one such ring, and then you integrate these rings, areas of the rings. So let's see what we get. 2 pi is constant, you can take it outside, and integral x dx from 0 to r. This integral already we have done. So what was the formula for integral x dx? X square by 2. Upper limit is r, lower limit is 0. And now we have to just put the upper limit 2 pi r square by 2 minus put the lower limit 0. So this will give you 2 pi into r square by 2. 2 cancel. So the answer is pi r square. Isn't this wonderful that you got the area of the circle from knowing the area of rectangle? That's beautiful, right?